In this lesson, we are going to learn how the patterns in a kaleidoscope are formed. Aren't these shapes beautiful? How do you think these symmetrical shapes are formed? Sir David Brewster of Scotland in the year 1816 invented the kaleidoscope. Sir David Brewster discovered that beautiful symmetrical patterns were made when loose pieces of glass and other objects were reflected by mirrors and lenses in a tube-like instrument. The symmetrical patterns varied when the mirrors were set at different angles or when different numbers. Brewster named this instrument kaleidoscope, which means beautiful form to see in Greek. A kaleidoscope consists of mirrors, which reflects material such as pieces of paper, beads, confetti, etc., placed at the end of the kaleidoscope. When the kaleidoscope is turned, the shape keeps changing. The kaleidoscope works based on the principles of physics and mathematics. A kaleidoscope consists of 2, 3, 4, or more mirrors that run the full length of the inside of the scope. The angles of the mirror will determine the number of reflections viewed. Click on each mirror system to know more about it. Two mirrors are arranged such that it forms a V shape and the third side of the triangle is blackened and non-reflective. The system is called a two-mirror. The number of reflections is determined by the angle between the two mirrors. For example, if the angle between the mirror is 10 degrees, the number of degrees in a circle, 360 degrees, gives 35 reflections, or an 18-point star, since 18 of the reflections will be reversed from the original. Number of reflections equals to 360 degrees over angle between mirrors minus 1. To know how such beautiful patterns of light are formed in a kaleidoscope, consider the center of the two mirrors to be O and mirror OA and OB. The object will be reflected off OA and OB to form virtual images in OAD and OBC, respectively. The virtual image of OAD and OBC will reflect off OD and OC, respectively, and form more virtual images, ODE and OCF. This continues way around the circle until a kaleidoscopic image is formed. So, starting with a 90-degree angle, the image produced would have 90 degree, 4-fold symmetry, 4-point star, 45 degrees, 8-fold symmetry, 4-point star, 36 degrees, 10-fold symmetry, 5-point star, 30 degrees, 12-fold symmetry, 6-point star, 22.5 degrees, 16-fold symmetry, 8-point star, 15 degrees, 24-fold symmetry, 12-point star, 10 degrees, 36-fold symmetry, 18-point star, 1 degree, 360-fold symmetry, 180-point star. A three-mirror system is similar to the two-mirror system, except that the non-reflective surface is now a mirror. So the light is reflected throughout the length of the kaleidoscope by three mirrors. It is difficult to get creative patterns in a three-mirror system. Creative patterns will be formed only when the mirrors are set at an angle which can evenly divide the 360 degrees. The possible angles for creative patterns are 30 degrees, 36 degrees, 45 degrees, and 60 degrees. Another important condition is that the sum of three angles is 180 degrees. So the possible combinations are 60, 60, 60 equilateral triangle. Here, each angle produces six-fold patterns which results in a design of continuous triangles. The second combination is the 45 degree, 45 degree, 90 degree isosceles right-angle triangle. This relationship produces eightfold patterns at the 45-degree angles and a fourfold pattern at the 90 degrees angle, effectively producing continuous square patterns. The third and most interesting is the 30-degree, 60 degrees, and 90 degrees right-angle triangle. In this case, all three angles are different, thus enabling three different symmetries: 30 degrees, 12-fold, 60 degrees, 6-fold, 90 degrees, 4-fold, to combine and form patterns. Square 4-mirror configurations produce repeated square patterns, while 4-mirror rectangular configurations produce repeated rectangular patterns. The images created are striped patterns since the reflections move directionally up, down, right, and left. Kaleidoscopes are classified based on the material it is filled with. Types of kaleidoscopes: the chamber kaleidoscope, the liquid chamber scope, the wheel scope, the refillable scope, the kaleidoscope. Chamber kaleidoscope has an enclosed object case. It is filled with free tumbling jewels, dichotic glass, beads, or other objects. The liquid chamber scope has an object filled with liquid, usually glycerine. The objects used for filling is jewels, dichotic glass, beads, or other objects. A wheel scope kaleidoscope has one or more wheels at its objective end. These may contain glass, translucent agates, pressed flowers, beads, or other objects. The refillable scope has a removable object chamber. The contents of the object can be changed and experiment with own assortment of colors and objects. The Kaleidoscope makes its magic with mirrors and lenses. Anything viewed appears multiplied. The Kaleidoscope transforms the whole world into a riot of kaleidoscope images. Most kaleidoscopes contain a simple equilateral three-mirror arrangement.
Perform the following activity and answer the following questions. Materials required for the activity: 3 small rectangular-shaped mirrors, all of the same size. Masking tape. Pencil. A piece of stiff, clear plastic. Scissors. A piece of waxed paper. Paper of different colors and textures. Use masking tape to hold the 3 small mirrors together so that they form the sides of a triangular prism. Trace the base of the triangular prism on the clear plastic sheet. Cut out the triangle. Repeat the step above to create another clear plastic triangle. Trace the base of the triangular prism on wax paper. Cut out the triangle. Cut the colored paper into small confetti-sized geometrical pieces. Create at least 3 to 4 different geometrical shapes. Attach masking tape along the edges of one of the plastic triangles in such a way that half of the tape sticks out. Make a sandwich of all the triangles. Start with the taped plastic triangle. Then place the wax paper triangle on top. Then add the cut-up pieces of colored paper. Place the other clear plastic triangle on top. Put the prism over the triangle sandwich and secure it in position with tape. Hold the kaleidoscope up to your eye and look towards a light. The pattern of the colored paper is reflected 6 times to make different designs. Shake the kaleidoscope to get a new pattern.
In this lesson, we have seen how an arrangement of mirrors produces multiple repeating patterns in a kaleidoscope.